There are moments in history when the very foundations of air combat are shaken, when one war exposes flaws so deeply that entire doctrines collapse. At the end of the 1960s, that moment arrived for the United States. The skies over Vietnam had revealed an uncomfortable truth. The Air Force had become so confident in technology, so convinced that missiles would make close-in dogfights obsolete, that they designed aircraft to be missile trucks rather than true fighters. And then, face to face with North Vietnamese MiGs, those assumptions fell apart. Heavy, multi-role jets that were supposed to dominate from beyond visual range were suddenly struggling against smaller, more agile opponents. Kill ratios suffered, pilots paid the price, and the US realized it had gambled on the wrong philosophy. Out of this crucible of failure came a demand that sounded more like a battle cry than a design requirement. Never again. The solution was not to create another jack-of-all-trades machine, but to go back to the essence of what air combat really meant. If you stripped away the myths, the slogans, and the false promises of over-engineered multi-role designs, you were left with one raw truth that every ace understood instinctively. In the sky, energy is life. The aircraft that can climb higher, accelerate faster, and maintain speed through turns dictates the fight. The loser is the one who bleeds away energy and finds himself trapped, unable to climb or escape. This was the philosophy that would guide the creation of the F-15 Eagle, a pure air superiority fighter built with one obsession: to win every aerial battle, to ensure that the words air supremacy were never again just a wish, but a reality carved into the sky. If you've made it this far, you're officially an honorary Eagle pilot. Don't leave the cockpit just yet. Hit that subscribe button and join the squadron, because the next mission is already loading. Imagine being a young engineer at McDonnell Douglas in the early 1970s, given a simple but terrifying mandate from the Pentagon: build a fighter that will never lose. The words sound heroic, but the weight of them is crushing. You know the statistics from Vietnam. You've read the reports of engagements where American jets, bigger and more expensive, were outmaneuvered by MiG-21s half their size. You know the public perception of air power is tarnished. The new aircraft would not be allowed to simply match the MiGs. It had to eclipse them in every measurable way. It had to carry enough thrust to climb like a rocket, enough wing to turn like a dancer, and enough technology to see and strike long before the enemy even knew it was there. For the Air Force, failure was not an option. For the engineers, it meant sleepless nights chasing the impossible. Out of this atmosphere of urgency was born the design that would change everything. The Eagle did not pretend to be stealthy, it did not pretend to be elegant, but it embodied raw power and uncompromising purpose. From the first sketches, its massive air intakes promised lungs that could feed hungry turbofans with oxygen at supersonic speeds. Its broad wings and slab tailplanes announced that this machine was built not for straight-line sprints, but for sustained combat where maneuvering energy meant survival. The fighter looked intimidating even on the drawing board, but it was more than just looks. It represented a philosophical rebirth of American air combat, a return to the roots of what a fighter was meant to be. This was not a bomber disguised as a fighter. It was a predator, and its prey would be anything that dared enter its airspace. But ambition alone does not win battles. Behind the scenes, the project was haunted by the ghosts of earlier mistakes. The Air Force remembered the F-111, an aircraft designed to do everything but excelling at nothing, forced into roles it could not handle. That lesson echoed like a warning siren. Do not dilute the mission of the Eagle. Every design meeting returned to the mantra: build it to win the dogfight, build it to climb, build it to accelerate. Any compromise that weakened those goals was rejected outright. The fighter would not carry the burden of ground attack, not at first. It would not be asked to strike ships or drop bombs on cities. Its soul was air superiority, nothing else. And that clarity, unusual in military aviation, became its greatest strength. What makes the Eagle's birth even more compelling is how audacious the promise was. By the time the prototype rolled onto the tarmac, the Air Force was already branding it with confidence. This jet would never be beaten in aerial combat. It was not just marketing, it was a declaration meant to restore credibility to American air power. And that boldness would later pay off, as the F-15 went on to carve a record of more than 100 victories in air-to-air combat without a single loss. But in these early days, that was still an untested dream. The engineers and pilots who first touched the Eagle were carrying not just a machine, but a vow. Every rivet, every panel, every curve of that frame was infused with the pressure of a promise to give pilots the edge that their predecessors had lacked, and to never let them fight blind or out of energy again. There is something almost poetic about the way the Eagle was introduced to the world. When it first lifted off in 1972, test pilots described it as if the aircraft wanted to fly before they even touched the stick. The power-to-weight ratio was so high that you could stand it on its tail and let it climb into the clouds. The control surfaces responded with such precision that pilots felt the machine was an extension of their bodies. It was not just another jet. It was a statement that America had reclaimed the air. The first flights sent ripples through NATO allies and shivers down adversary spines. The Soviets, watching closely, realized they were facing a generation-defining challenge. This was not a marginal improvement, it was a leap. To understand the gravity of this shift, consider the context of the Cold War. Every fighter was more than a machine. It was a chess piece in a global game where perception mattered as much as performance. If the Eagle succeeded, it would tell the world that American pilots would always enter battle with the upper hand, and if it failed, the opposite message would echo just as loudly. That is why the first flights, the first evaluations, the first reports were not just technical milestones, but geopolitical events. When test data confirmed that the aircraft could climb faster, accelerate harder, and outmaneuver anything in the sky, confidence surged. The legend of invincibility was being written not by propaganda, but by flight tests. Yet even at its birth, the F-15 carried a burden that would follow it throughout its life, the need to justify its cost and complexity. It was massive compared to its predecessors, demanding expensive maintenance and significant resources. Critics called it overkill, a machine built for duels that might never happen. But those doubts only made its champions double down. They believed that if even one air battle was decided by the Eagle's ability to dominate, the price would be worth it. And when the first combat deployments arrived, history would prove them right in a way no one could ignore. The opening chapter of the Eagle's story is therefore not just about blueprints and test flights. It is about redemption, about rebuilding trust in American air power after a painful era of miscalculation. It is about engineers and pilots daring to declare that defeat was no longer acceptable. It is about the moment when energy became the guiding principle of design, and when a promise of air superiority was reborn in metal and fire. The F-15 Eagle entered history not quietly, but with the roar of engines that signaled a new era. And that roar still echoes, setting the stage for how this aircraft would not only meet its bold promises, but exceed them in ways few could have imagined. When you first stand beneath an F-15, its presence is overwhelming. It does not look like a machine built for subtlety or compromise. Its massive air intakes gape like open lungs ready to inhale the sky, while its wide delta-shaped wings stretch out with a promise of strength and agility. At a glance, it is all brute force, but every curve, every angle, and every surface is part of a carefully orchestrated design philosophy. The F-15 structure was not about elegance in the artistic sense, but elegance in engineering. A machine honed to turn energy into control, to take raw thrust and translate it into dominance in the air. It was a fighter that had to outperform everything that came before it, not only in speed, but in the ability to fight without ever losing momentum. The size of the wings alone tells a story. At over 600 square feet, they provide a massive lifting surface far larger than many contemporary fighters. This was not wasted area, but a deliberate choice. Large wings allowed the Eagle to generate lift even at high angles of attack, where other jets would stall and tumble. With the Eagle, the pilot could push harder, bank steeper, and pull tighter turns without sacrificing as much speed. The concept was simple but deadly effective. Maintain energy while forcing the enemy to bleed theirs. In combat, this meant an F-15 could stay in the fight longer, dictating the rhythm until the adversary had no room left to maneuver. Pilots often described it as flying a machine that always seemed to have more in reserve, a quality that built confidence with every mission. Then there were the iconic rectangular intakes positioned low and forward beneath the cockpit. These were not just functional, they were critical to the Eagle's ability to transition smoothly from subsonic to supersonic flight. Adjustable ramps within the intakes could redirect airflow as speeds climbed, feeding the engines a steady, controlled stream of air even at Mach 2.5. To the casual observer, they were just openings, but to engineers, they were marvels of aerodynamic engineering, the difference between an engine choking on shock waves and an engine thriving in the thin air of high altitude. For pilots, it meant they could push the throttle without fear. Knowing the intakes would handle the violent transition into supersonic regimes, the fuselage itself was built with a blend of strength and lightness that reflected the lessons of Vietnam. Where earlier fighters had often sacrificed maneuverability for structural reinforcement, the Eagle used advanced alloys, including carefully placed titanium, to keep weight low without sacrificing durability. The result was a jet that weighed less than its imposing size suggested, making it more responsive to control inputs. Test pilots remarked that the F-15 seemed to anticipate their moves, rolling, pitching, and climbing with a grace that belied its bulk. This responsiveness, combined with the immense power of its engines, meant that the Eagle could transform from a climbing rocket to a turning predator in seconds. Aerodynamics played a crucial role in the Eagle's dominance. At the root of each wing was a subtle extension known as a lurx, a leading-edge root extension. These small but powerful features generated strong vortices at high angles of attack, energizing the airflow over the wings and delaying stall. In combat, this gave pilots the confidence to pitch the nose higher without losing control. Imagine a knife fight in the sky, where both aircraft are circling and jockeying for position. The one that can keep its nose pointed toward the opponent without stalling has the advantage. In countless engagements, this aerodynamic edge made the difference between firing the first shot and being forced into defense. The tail design also revealed the Eagle's priorities. Twin vertical stabilizers provided stability at extreme angles, while the large horizontal stabilizers acted as powerful control surfaces, giving the aircraft authority even when pushed to its limits. Together, these surfaces made the F-15 feel less like a heavy machine and more like a living extension of the pilot's will. In training exercises, Eagle pilots found they could force opponents into overshooting maneuvers, using their superior control to position themselves for clean missile locks or gun solutions. Stories quickly spread across squadrons. If you were in a turning fight with an Eagle, you were already in trouble. One of the most remarkable structural achievements of the F-15 was its ability to sustain high G maneuvers without tearing itself apart. The jet was designed to withstand loads up to 9 Gs, meaning pilots could pull maneuvers that pressed their bodies into the seat with 9 times the force of gravity. To put that in perspective, an average person would struggle to remain conscious at half that force, yet the Eagle's pilots trained to endure it, while the aircraft itself shrugged off the strain as if it were routine. This combination of human endurance and mechanical resilience allowed the F-15 to push engagements into realms where less capable aircraft simply could not follow. But perhaps the most underrated part of the F-15's structure was not what you could see, but what was hidden within. The airframe was designed with significant growth potential, meaning it had space and strength to accommodate systems that did not yet exist at the time of its first flight. This foresight would later allow the Eagle to integrate advanced radars, avionics, and weapon systems without losing performance. In many ways, the skeleton of the aircraft was a canvas, ready to be adapted as technology evolved. It is one of the reasons why, decades after its debut, the Eagle remains relevant while other contemporaries faded into history. The impact of these design choices became clear the first time the F-15 squared off against adversary aircraft in exercises. Against agile but lightly powered fighters, the Eagle's massive wing area and thrust allowed it to simply outlast opponents, circling until the enemy had no energy left. Against larger, faster jets, its maneuverability ensured it could force the fight into close quarters, where its control authority gave it the edge. It was not just one feature that made the Eagle superior, but the integration of all of them: lift, thrust, aerodynamics, and control surfaces working in harmony. Every pilot who strapped into the cockpit knew they were flying something that had been engineered not just to survive combat, but to dominate it. And yet, as impressive as the structure was, it was only one side of the equation. A fighter could have the best airframe in the world, but without engines capable of delivering relentless thrust, it would still fall short. The next step in the Eagle's story moves from the shape of its wings and the strength of its frame to the roaring heart that gave it life. The story of the F-15 cannot be told without the story of the engines that propelled it to altitudes and speeds where legends are made. At the core of every fighter lies its engines, and for the F-15 they were nothing less than its defining feature. The sleek shape and wide wings gave the Eagle its agility, but without the raw thrust roaring from its twin turbofans, it would have been just another aircraft, limited by the physics of weight and drag. What set the F-15 apart from its peers was the audacity of its designers to insist on a ratio of thrust to weight greater than 1, a radical idea at the time. In simple terms, this meant the aircraft could accelerate while pointing straight up. For the first time in aviation history, a fighter could truly climb vertically without stalling, behaving more like a rocket than a jet. Pilots who first flew it described the sensation as unnatural, almost disorienting, to push the throttle forward and feel the machine surge skyward with no sense of struggle. It was as though the jet was defying the laws that had governed flight for decades, rewriting what was possible in aerial combat. The engines responsible for this transformation were the Pratt & Whitney F-100 turbofans, revolutionary in their own right. Producing over 23,000 pounds of thrust each in afterburner, they made the Eagle a machine that could accelerate through the sound barrier with frightening ease. The sound of those engines in full afterburner was described by ground crews as a physical experience, not just an auditory one, a thunder that rattled bones and windows alike. But power alone was not enough. The engines had to be reliable under extreme conditions, able to cope with rapid throttle changes, sudden dives, and violent maneuvers without flaming out. Early versions struggled, plagued by compressor stalls that sent flames shooting out of the intakes. Test pilots had to wrestle with unpredictable surges of power, and more than once, prototypes were nearly lost. It was a painful reminder that revolutionary performance always came at a cost. Engineers worked tirelessly to refine the engine controls, and over time, the F-100 matured into one of the most dependable power plants of its generation, its quirks ironed out through countless hours of trial, error, and persistence. Once perfected, these engines gave the F-15 its signature combat style. The Eagle could accelerate out of a turning fight, climbing higher than opponents who were forced to bleed speed. It could zoom past the vertical, roll over the top, and dive back down with energy still in reserve. In dogfight training, instructors would warn adversaries not to chase an F-15 into the vertical because the outcome was predictable. The Eagle would simply keep going while the pursuer ran out of lift and fell away helplessly. This dominance in the vertical fight became one of the jet's trademarks, giving it an almost unfair reputation in mock battles. Pilots began to believe, with good reason, that as long as they managed their throttle correctly, they could outlast and outmaneuver any opponent in the sky. But the story of the Eagle's heart does not stop at brute force. The engines were only one half of the sensory equation. Just as the body requires both muscle and vision to function, the F-15 needed not only thrust, but the ability to see further, track more, and strike before an enemy could even respond. This is where its radar system became equally legendary. From the beginning, the Eagle was equipped with a radar powerful enough to detect and track targets beyond visual range, a capability that turned it into more than just a knife fighter. With the AN/APG-63 radar, pilots could engage threats long before merging into visual combat, guiding missiles onto targets miles away. It was one of the first radars with look-down, shoot-down capability, meaning it could pick out low-flying aircraft against the clutter of the ground. In the Cold War, when adversaries were expected to sneak in under radar coverage, this was a decisive advantage. The presence of such advanced radar transformed how pilots thought about combat. No longer were they limited to closing in before having a chance to fire. Instead, the F-15 could control the battle space from afar, forcing enemies into defensive positions before they even realized they were under threat. Stories from training exercises are filled with tales of adversary pilots frustrated by being killed in scenarios without ever seeing their attacker. The Eagle had turned air combat into something asymmetrical, where its opponents were always on the back foot. This sense of invincibility was not just a matter of propaganda. It was reinforced every time the radar picked out an enemy hiding in the ground clutter and guided a missile to its mark. Technology did not stand still, and as decades passed, the radar systems inside the Eagle evolved dramatically. Upgrades led to the APG-70, and later to active electronically scanned array radars like the APG-63, V3, and APG-82. These new generations offered not only more range, but the ability to track multiple targets simultaneously and shift between modes instantly. A pilot could be monitoring threats in the air, while simultaneously mapping the terrain below for strike missions. The precision was extraordinary. Rather than relying on a single beam sweeping back and forth, the radar could redirect its beams electronically in microseconds, like a spotlight flicking from one target to another without pause. To the pilot, this meant a clearer picture of the sky, faster updates, and the ability to make decisions with confidence even in chaotic battles. Inside the cockpit, the impact of these advances was equally striking. The early Eagles already emphasized clarity, with heads-up displays showing essential data, so pilots could keep their eyes on the fight. But with the F-15EX, the evolution reached a new level. The cockpit became dominated by a large area display, a single digital screen capable of presenting multiple layers of information simultaneously. Radar tracks, weapon status, navigation data, and electronic warfare cues could all be fused together in a single coherent view. Pilots described it as stepping into a control room where every piece of information was arranged at their fingertips, reducing the chaos of combat into something manageable, almost intuitive. This was not just about convenience. It meant faster reaction times, fewer mistakes, and more effective coordination with Allied forces. One of the most fascinating aspects of the Eagle's systems was how they were designed to evolve alongside technology. The jet was built with space, power, and cooling capacity to handle electronics that did not yet exist at the time of its creation. This foresight allowed the radar, avionics, and cockpit systems to be upgraded repeatedly without redesigning the airframe. It was as if the engineers of the 1970s had left room for the future, anticipating that the world of sensors and computing would change more rapidly than aerodynamics or engine design. Decades later, that vision proved correct, keeping the Eagle at the forefront of combat aviation while others from its era were retired. The combination of unmatched thrust and unparalleled vision gave the Eagle a balance no other fighter of its time could achieve. It was not just fast, and it was not just smart. It was both at once. Pilots could accelerate vertically into the heavens and still maintain radar lock on a target below. They could dive at supersonic speed, confident that their systems would track and guide them to the kill. Every part of the Eagle's design came together here, where the roar of its engines met the silent precision of its sensors. This marriage of muscle and mind is what made the F-15 so feared, so respected, and so impossible to defeat in air-to-air combat. And yet, the story of the Eagle's dominance was not complete without the weapons it carried, the claws that turned power and vision into actual victory. To understand why the F-15 became the embodiment of aerial supremacy, we must move from engines and radar to the missiles and guns that defined its kill record.